the return address type and values. The return address type is used by the Java virtual machine, GSR, read and GSRW instruction. The value of the return address type are pointers to the opcodes of Java virtual machine instruction, unlike the numeric primitive type. The return address type does not correspond to any Java programming language type and cannot be modified by the running program. 2.3.4 The Boolean type. Algorithm of the Java virtual machine defines the Boolean type only provides very limited support for it. There are not Java virtual machine instructions solely dedicated to operations on Boolean values. Instead, expression in the value programming language that operate on Boolean value are compiled to use value of the Java virtual machine in data type. The Java virtual machine doesn't directly support Boolean array. Its new array instruction enable creation of Boolean array of type Boolean are accessed and modified using the byte array instruction by load and bar store. In Oracle Java Virtual Machine implementation, Boolean array in the Java programming language are encoded as Java Virtual Machine byte array using 8 bits per Boolean element. The Java Virtual Machine encodes Boolean array components using 1 to represent true and 0 to represent false. The Java programming language Boolean value are put by compilers to value of Java virtual machine type integer. The compiler must use the same encoding reference type and value. There are 3 kinds of reference type: class types, array types, and interface types. Their value are referenced to dynamically created class instance, array or class instance, or arrays that implemented interface representatively. And array types consist of components type which a single dimension, though length is not given by the type. The component type of an array type may itself be an array type if starting from any array type one considers its component type, and then if that is also any array type, the component type of that type, and so on. Eventually, one must reach a component type that is not an array type. This is called the element type of the array type. The element type of an array type is necessary either a primitive type or a class type or an interface type. The reference value may also be the special null reference, a reference to an object which will be denoted here by null. The null reference initial has no runtime type but may be cast to any type. The default value of a reference type is null. This specification does not mandate a concentrate value encoded in null. Runtime 2.5 Runtime data arrays. The Java virtual machine defines various runtime data arrays that are used during execution of a program. Some of these data arrays are created on Java virtual machine startup and are destroyed only when the data virtual machine exists. Other data areas are per thread data areas are created when the thread is created and destroyed when the thread exists. 2.5.1 The PC register. The Java virtual machine can support many threads of execution at once. Each Java virtual machine thread has its own PC program counter register at any point. Each Java virtual machine thread is executing the code of the single method, namely the current method for that thread. If that method is not native, the PC register contains the address of the Java virtual machine instruction currently being executed. If the method currently being executed by the thread is native, the value of the virtual machine Java virtual machine PC register is undefined. The Java virtual machine's PC register is wide enough to hold a return address or a native pointer on the specific platform. 2.5.2 Java virtual machine stacks. Each Java virtual machine thread has a private Java virtual machine stack created at the same time as the thread Java virtual machine stack stored frame. Java virtual machine stack is analogous to the stack. The conventional language such as C, it holds local variable at partial results and buys a part in method invocation and return. Because the Java virtual machine stack is never manipulated, they are directly accepted to push and pop frames. Frames may be chip allocated. The memory for a Java virtual machine stack does not need to be contiguous.
Contiguous.
In the first edition of Java Virtual Machine Specification, the Java Virtual Machine stack was known as the Java stack. The specification primitives Java Virtual Machine stacks either to be of a fixed size or to dynamically expand and contract as required by the computation. If the Java virtual machine stacks are of fixed size, the size of each Java virtual machine stack may be chosen independently, then that stack is created. A Java virtual machine independent implementation may provide the programmer or the user control over the initial size of Java virtual machine stacks, as well as in the case of dynamically expanding or contracting Java virtual machine stacks, control over maximum and minimum size. The following exception conditions are associated with Java virtual machine stacks. If the computation in a thread requires a largest Java virtual machine stack, then is permitted the Java virtual machine throw a stack overflow error. If Java virtual machine stack can be dynamically expanded and expansion is attempted but insufficient memory can be made available to effect the expansion, or if insufficient memory can be made available to create the initial Java virtual machine stack for a new thread, the Java virtual machine throw an out of memory error. 2.5.3
Como para bicho, ele mexe. они в личные сообщения, да?
Да.
Можно написать, что, чтобы они не и в общем, во личку.
Да. .5.3 chip. The virtual machine has a chip that is shared among our Java virtual machine thread. The heap is the runtime data area from which memory for our class instance and arrays. Is allocated. The chip. Нужно и так, наверное. The chip is created in virtual machine startup heap storage for object is reclaimed by an automatic storage management system known as garbage collector. Objects are never explicitly relocated. The Java virtual machine assumed no particular type of automatic storage management system, and the storage management technique may be chosen according to the implementer's system requirements. The chip may be of fixed size or may be expanded as required by communication, and may be contracted if a larger chip becomes unnecessary. The memory of the units does not need to be contiguously. Физические дефекты.
Contiguous.
Физические недостатки. Физическая ущербность. Кандидат убийцы. Java machine documentation may provide the programmers or the user control over the initial size of the heap, as well as if the heap can be dynamically expanded or contracted. Control over the maximum heap size. The following exception condition is associated with the heap. If a computation requiring more heap than can be made available by the automatic storage management system, the Java virtual machine throw an out of memory error. Method area. The Java virtual machine has a method area that is shared among our Java virtual machine thread. The method area is analogous with the storage area from compiled order of a conventional language or analogous of the text segment in operation system processes with storage class structures such as the runtime constant field and method Java, and the code for method and constructor include the special method used in class interface initialization and in instance initialization. The method area is created in virtual machines up through the method area is logical part of the chip. Simple implementation may choose not to use a garbage collector or compact it. This specification does not mandate the location of the method area or the policies used to manage it. Compiler code. The method area may be of a fixed size or may be expanded as required by the computation and may be contracted if large method area becomes unnecessary. The memory of the method area does not need to be contiguous. The Java virtual machine implementation may provide the programmer or the user control over the initial size of the method area, as well as in the case of a varying size method area, control over the maximum and minimum method area size. The following exceptional condition is associated with the method area. If memory in the method area cannot be made available to satisfy an allocation request, the Java virtual machine throws an out of memory